Here are the battery and charger options we have for the robot course. This is the biggest one we have. A 16-volt Lipo pack with 4 cells. Lipo stands for lithium polymer. This battery can deliver very high currents, which is why the main wires are so thick. The thinner wires go to each one of the 4 cells, so one can check what the voltage on each of these cells is. This big battery will provide the power for all your drivetrain needs and also servos and actuators. Lithium batteries are charged with special chargers, and we have these 2 types for the course. The bigger ones are a bit older, but they do essentially the same thing as the smaller and newer ones. For your robot control circuits, we have several other options. First, there are these small 2-cell Lipo packs with around 8 volts. And while these smaller batteries can also be charged with those large chargers, we now also have some small USB chargers that can be used with any cell phone wall brick or even charged using your laptop. The next option to power controls is this 9-volt block. That is actually a Lipo battery internally, and it can be recharged with any USB-C type power source. And the last option we offer are standard 9-volt block batteries, the non-rechargeable alkaline type. They are a bit wasteful since they have to be thrown out when they're empty. When you're using the 16 and the 8-volt Lipos, you always have to attach one of these things. They are little voltage alarm modules. They attach to the smaller plugs with the many wires, and when you look at the labeling on the backside, you can see that the outer pins are labeled with a plus and a minus. To plug them in right, just make sure that the black wire from the battery attaches to the negative pin on the alarm. When you plug it in, it will beep, and then it will show you the total battery voltage first, and then scroll through the voltage of each of the cells that the battery has. The point of this module is to see what state of charge your battery is in. These batteries are full when the cell level voltages are around 4.1 to 4.2 volts. When they go to below 3.5 volts, the battery is considered empty. If they go below 3 volts, the battery is starting to die. Never use a battery that has been less than 2.8 volts. There's a little button on top of the alarm. Push it and set that 3.5 volt alarm level. So you make sure that if any of the cells ever goes below 3.5 volts, the battery alarm will beep, and then you know you need to recharge. If you ever have a battery that is having any cell that is lower than 2.8 volts, do not charge it again. This has to be recycled. This could be a fire hazard. The voltage alarm has to be unplugged when a battery is not in use because it can drain the battery empty and kill it. So when you leave at the end of the day, make sure to unplug everything, including the alarms, and set all your batteries somewhere near a bench corner so we can actually check and make sure that nothing stays plugged in overnight. These batteries are kind of expensive and we don't want to waste any of them or turn them into a fire hazard. Talking about fire, if you ever have a fire problem with one of the batteries, take it out from your robot and dump it in one of the buckets and then pour some sand from the other bucket on top. And then tell us about it and we'll deal with it. Next is fuses. As mentioned before, these Lipos can do crazy currents. This one, for example, is rated 130 Cs, which is a factor to multiply with the nominal capacity, and that will tell you what the max current is that this battery could deliver. In this case, 1.3 amp hours capacity for the battery times 130 Cs comes out to around 200 amps, 195 amps, which is really way more than you would ever want to see anywhere in your robot. This is the kind of current that you see in welders, and shorting your battery without a fuse will look just as if you are welding. It's not a pretty sight. So you have to use a fuse with the big battery pack. There are different ways of doing this. We do have these fuse holders that connect to the pack. The other end can be wired to your power distribution board, either by soldering the wire directly to it or by soldering a matching connector to the board and then plug in that fuse holder. That soldering of the connector to the board is a bit of a hack, but it's doable. That board will then become your power distributor, and from here you'll go to each of your H-bridges and other items such as voltage regulators to power your 5-volt servo motors, for example. These fuse holders and the wires and all that can get a bit unwieldy and take up a lot of space. If you don't like that, one possible way to get around it is to integrate your fuse with your power distribution board. This can be done with automotive spade connectors, these things. They do match the fuses, and you can strip the little red bit and then solder these connectors directly to a PCB. If you decide to do this, make sure to cover all exposed connector bits with shrink wrap after you've soldered them on, and cover the back of your board with hot glue or electrical tape or both. Otherwise that thing becomes a fire hazard on its own. There are all kinds of ways to do this. We have different harnesses and connectors and pigtails. You can cut them and configure them exactly the way you like. You should check out robots from previous years to see what they have done. Next is charging. These 16 volts and 8 volt batteries are charged using the small voltage alarm connectors. So you unplug the voltage alarm and then you use these connectors, plug them into the correct port on the chargers. Only charge one battery at a time. Any more than that can cause a fire. Don't plug in two at the same time. The chargers are plugged into your lab power supply. Before you plug them in, first set the voltage on your power supply to 15 volts and then crank the current limiter to max. Your supply needs to be healthy and needs to be able to deliver at least 2 amps or better a bit more. And you can check that by shorting the outputs and turn the current limiter to max while you're shorting it. You will see the current go up and you want to see at least 2 amps and more. The big charger has a sliding switch for the charge current. Set that one to 1 amp. The small is not adjustable. The big charger has indicator lights that tell you when the battery is full, and the small one shows the voltage. Full is, as I said, when the batteries get to 4.1 volts or maybe 4.2 max each. These chargers should automatically limit this, so you should not be able to overcharge the batteries. But if they malfunction and you ever see the voltage go higher than 4.2 volts, make sure to give us that charger. It is probably damaged, and also give us the battery, since that will need to be recycled. The 9 volt block batteries are easier to use. All you need is a 9 volt battery clip, and you can solder that directly to a PCB. No fuse is needed, but always try to make sure that there are no shorts, since that will kill the battery or at least drain it empty in no time. The 9 volt Lipo blocks with the USB-C type charging port, they have one weird thing, and that is they sometimes need to be reset to get them working. You can see when the output is not showing anything sensible, like low voltage, it should be 9.3, 9.5, something like that. So if you don't get anything out of it, you might have to reset the battery, and this is done by briefly plugging them into a charger. These 9 volt Lipo blocks are also the only batteries that are okay to leave on a charger overnight. One more detail. Some of the 2-cell 8 volt Lipos, they don't have power leads. They only have the Lipo alarm leads. For these ones, you will have to make a little adapter to break out the main voltage to your PCB and to be able to connect both your PCB and the alarm module at the same time. This is fairly easy to do, and it looks like this.